Awesome. So to start off, thanks to everybody for making time out of your busy days to come chat with us for a little while. Like Pete said, this is going to be recorded, as well as the sample code is going to be all packaged up together. And you'll get an email afterwards with everything that we went through. We've been doing these every 2 weeks as just a way to build some regular time to chat with the Airflow community. This week's is going to be led by Pete DeJoy, who's one of our product managers, and it's going to be all about the Airflow ecosystem, primarily with what's changed in Airflow 2 and how that'll make your lives easier as Airflow users. Like all of these, please feel free to ask questions in the chat or the questions tab in AirMeet. And yeah, let's just make this a conversation. We have some slides and some code to run through, but we love the conversation and just the community aspect of this. So feel free to say whatever comes. Pete, with that said, I'll hand it off to you.
Yeah, thanks, Viraj. Heck of an intro. Yeah, as Viraj said, I'm Pete. I work on product here at Astronomer. I've been here for quite some time working on Airflow. Really excited to chat with everybody today. Again, we do like doing these things as kind of conversational lunch hours. Feel free to ask questions. A little bit more casual, less formal. At the end of this, or a little bit later on, we'll be inviting on stage some of our partners from over at Fivetran to talk through how they've kind of tapped into the Airflow ecosystem to build a great integration with Fivetran that we're excited to show off. So looking forward to having them on as well. But for starters, I'm just going to walk through a couple slides on Airflow Providers and the Airflow Providers framework at large, why it exists, how it works, what's up with all the jargon that you might have tried to reconcile at some point in your time exploring Airflow, and then talk about how you might leverage it in your day-to-day work writing DAGs. So let's see if this screen share works here.
Most fun part of all the webinars is seeing if the screen share is working. You're looking good.
All right, you can see my deck, right?
Yep.
Wonderful. Cool. So I'm just going to talk a little bit in the abstract about Airflow Providers. Again, Viraj, you know this, but I can't see like the webinar chat. So if people are dropping questions in there, feel free to just interrupt me at any point along the way. And we can, again, this is much more designed to be more of a conversational roadmap than anything super formal. But yeah, I'm going to assume that folks here are, might have some knowledge about the provider framework in Airflow, but I'll walk through it from first principles just to give you a quick primer on what it all means. So generally, in the abstract, Airflow loves the data ecosystem, right? We all know that Airflow is a big fan of all of the tools that users use in their modern data pipelines. By the nature of what orchestration is, it naturally requires tight integration with many different tools and services to empower certain contextual outcomes, right? You might use a bunch of different tools to write your ELT pipelines or ETL. You might be using a completely different set of tools to do some more machine learning, model training, and model serving. Airflow is really designed such that it has a nice integration with many different tools to accomplish well understood outcomes. So again, there are all these tools that developers like the folks here use every day in their data pipelines when they're writing DAGs, and very often they need to schedule jobs from Airflow to help support those usage patterns. So naturally, Airflow does need to have a very tight integration with many different things. So the Airflow operator framework, not to be confused with the Airflow provider framework, which we're discussing today. The Airflow operator framework is the lowest level of abstraction of how Airflow users plug into these tools that we were just showing off on the previous slide. This operator framework has been used extensively for many, many years by the Airflow community. It is modular, extensible, repeatable, and maintainable. But all that really means is that it's what you find at the middle of a Venn diagram between customizability and reusability. What Airflow operators are patterns, right? They give user access to source code if they need to make any modifications to API abstractions or transformation logic or anything of the sort. But users are also given a rich ecosystem of boilerplate building blocks so that they don't need to reinvent the wheel every time they want to add a task to their DAG or help kind of integrate with a separate tool.
So one thing I've heard from a lot of members of the Airflow community is operators are great in terms of getting you 80% of what you need, and then the last 20% you'll probably have to make a small change to make work for your specific use case. And I think that's why they've gotten as popular as they have, because it gets started and then leaves you enough room to make the changes you need for your custom use case.
Yeah, exactly, right? Like I want as much boilerplate as I can get while also being able to configure that last 20% to fit my use case. So just to give an example of what this might look like in practice for folks who haven't used Airflow Operator before, we have this kind of sample DAG that has a lot of logos on it, but you can imagine a use case where we're loading data into some sort of object storage from legacy data systems, performing some sort of data processing against it, and then doing some downstream kind of AI work against that data. What the Airflow Operator framework allows you to do is easily implement new data sources here. For example, if we wanted to add data coming from some Kafka topic into that object storage, it's quite easy to just plug in using Airflow Operator. So again, really good boilerplate patterns and really extensible to accommodate new usage patterns as DAGs continue to evolve. So taking that operator concept, operator framework at large, and abstracting it out to what it really means in the Airflow community. And these are probably words that you've seen before if you've worked with Airflow. Maybe you have a good understanding of what all these things mean. Maybe you're wondering what the heck they all mean. But basically, like in the Airflow ecosystem, there aren't just operators. There are many different kinds of modules that help abstract some sort of logic. So you have hooks, which help establish some connection to third-party data stores. You have operators, which perform some sort of predefined logic that are tailored to specific use cases. It can be some sort of action. It can be a transfer of data from an S3 bucket to a GCS, GCS bucket. It can be a sensor, which waits for some predefined criteria to be met before executing some logic. But at the end of the day, these are all just modules that are bundled into providers. And this is where the providers framework really comes into play. So providers, if you think of operators in these hook modules as kind of the bottom level abstraction over APIs, providers are packages that encompass all of these different integration points relevant to a specific service provider. So, the AWS provider contains all modules relevant to AWS services, operators for, ECS, for data sync, for CloudWatch, etc. Same thing with Snowflake. So just to have a bit of a prettier visual of what that might look like, with the provider being the package that is relevant to a service provider and the module being the actual low-level abstraction layer, what the Airflow Providers framework does is really give you a really clean and nice system by which you can access all of these integration points to use in your DAGs and data pipelines.
So Pete, let me make sure I'm understanding that right. So Airflow gives you the framework to write DAGs, which let you express how your workloads can be run. And then one layer higher than that, it gives you the framework for providers, which lets you actually govern how your workloads connect to different sources. Is that the right way to think of it?
Yeah, exactly, right? Like your providers basically are the packages containing any sort of bits that you might need to interface with any sort of service provider that you use in your stack.
Interesting. That's awesome.
Give a little bit of provider history as well, just to give some color as to how this has all changed with Airflow 2.0, which was released in December. Before Airflow 2.0, providers were bundled into core Airflow releases. So that meant that the code powering all of these operators in these providers that weren't packages yet, were released with the Airflow binary and code base. So every time that you wanted to release a new operator within a provider directory, you needed to wait for an Airflow release for updates or changes to take effect. And this also meant that users would import their operators directly from Airflow instead of from the actual provider itself. This introduced quite a lot of maintenance overhead for the Airflow community. It also meant that there wasn't as much, iterative development that could take place within the actual kind of module itself, because the users had to wait for entire Airflow releases for updates to those integration bits.
So what you're saying when we think about all the reasons providers were great is that, in pre 2.0, providers were customizable and repeatable, but they weren't really maintainable, it sounds like, because any change I make, I'd either have to maintain as a fork or I'd have to wait a full release cycle to get that into core Airflow.
Exactly. And obviously, Airflow as a project has a lot going on. There's a lot of super complex bits in there that the community does such an amazing job of maintaining and releasing. Sometimes it could take a little bit of time to, receive those changes as a user, again, without maintaining a fork. So what the community did in Airflow 2.0, which was a huge milestone, was actually decouple providers from the core Airflow release. So this means that providers are now able to be independently versioned, maintained, and released because they're being distributed as their own Python packages, i.e. that AWS provider that we mentioned before is now being cut as its own package independently of the core Airflow project. So if AWS changes, I don't know, like one of their APIs, right, like bumps a version of their API, the provider can change to accommodate that immediately without having to wait for an entire new Airflow release. It also means that users now just pip install the provider package and import modules into their DAG files, so they don't actually get things that they don't need in their core Airflow distribution. They're able to install only the providers that they actually need to use in the context of their data pipelines. And most interestingly to me personally, it means that providers can now be built from any public repository. They no longer have a hard dependency of living inside the Airflow monorepo, which empowers a lot more plugin and integration freedom for folks who are looking to build provider packages and share custom code. So again, go ahead.
I was going to say, Pete, on that first one, does that mean that I can change a provider without having to upgrade all of Airflow? I've spent so much time trying to do that before just for one new operator. Is that what you're telling me?
Yep. You can just bump a provider version. It's compatible, and you get the latest and greatest without having to wait. So again, like this also kind of insinuates higher quality, more iterative dev cycles on provider packages. APIs can be guaranteed to be kept relevant within all the modules contained. It also means that since users now pip install their providers, right? Again, these providers can now be built from any public repository without fracturing the core developer experience, because they're just Python packages that you're including in your Airflow environment, your requirements, and all of the modules can just be imported into DAG files, from the get-go.
So, question in the chat that's relevant to that. I think one thing in the past people struggled with is when you're upgrading all of Airflow. There's a bunch of conflicts between what your environment had and what you're upgrading to. So a question from Darsh in the chat is, what if the packages in the provider provide some sort of conflict? A Python conflict with what I'm running right now.
Yeah, like there's a ton of testing being done by the community. They're doing amazing work around making sure that providers are compatible with the latest version of Airflow. But again, like one of the great things that this allows users to do is actually pin versions of the provider package themselves, right? And test upgrades super diligently in a staging environment to make sure that there are no introduced dependency conflicts that would break any logic that lives in their DAGs. So just introduces a much higher kind of degree of responsibility and reliability you're using some of those open source operators.
That's awesome. And then what about this pip install packages? What does that mean for if I am writing providers to be used by my end users compared to the old? I know I used to have to maintain submodules and things like that in order to make it so my users are using the right versions of my custom operators. Are you saying that piece got simpler as well?
Yeah, completely. So one of the beliefs that we have is that folks who maintain third-party tools are the best arbiters for abstractions over their APIs. So they're the best folks to dictate how users should consume their APIs from Airflow. What this allows us to promote is this pattern such that the third-party provider can actually build and control the source code powering their provider and maintain that as well, right? So if their API changes, or if they want to change, or they want to add an operator to interface with a new endpoint that they're exposing, or anything of the sort, it's very easy to do that and just cut a new release of the package so it's available to the Airflow community immediately, without having to have a hard dependency on any sort of Airflowy bits. We think this actually drives a ton of value for the community, because it means that service providers, people that are building great tools, are much more much more likely and much more incentivized to get more involved in the ecosystem and community to help build a great user experience at the intersection of their tool and Airflow. Again, this leads to a much higher quality and much higher volume of integration opportunities for Airflow developers to leverage.
So question around that in the chat is, can I package up my Airflow providers so that they are launched with Kubernetes pod operators? Is that something that this makes easier?
Yep. Yeah, completely. So because they're, again, releases their own Python packages, you're able to install them into a fresh Kubernetes pod, a fresh operating environment. Again, like this is something that folks have done in the past to guarantee that there won't be any dependency conflicts or anything of the sort. But yeah, you can launch a Kubernetes pod, install the package into the pod, and leverage any of the operators within that package as your task. So it makes it much easier to maintain that separation of concerns.
Awesome. That'll be great, because I know I like to make it so my users don't have to worry about dependency conflicts at runtime. So if I can just package my provider to launch as a pod, that makes it so much easier for me as a service provider to my customers.
Completely. Yeah, we've definitely seen a lot of users start to kind of abide by that pattern, and it makes it really easy just to access any sort of predefined logic directly in a fresh operating environment. So yeah, as folks here may or may not have seen, last week we at Astronomer launched a product called the Astronomer registry to help support the providers framework and the Airflow, help the Airflow use more of the providers framework. If you haven't seen this, you can check it out at registry.astronomer.io. It's live up there as of early last week. Going to walk through a demo of what it actually looks like and what it means for the community in just a sec. But really what it's designed to do is, one, help users consume more of the providers framework, and two, help anyone from a major technology company to an individual developer writing DAGs to publish a provider from any public repository. So again, even if you're just an engineer who has written a series of custom operators or hooks that they're particularly proud of, it's now really easy to package those up and make them discoverable by the community, so that we can really start to build out an ecosystem of folks who want to share some of the code they've written with other Airflow users. So yeah, Viraj, interrupt me if there are any questions too along the way here, but I can just walk through what this actually looks like for an Airflow user that's writing a DAG and how it might be able to help them, consume some predefined pieces of code that exist in the ecosystem.
Yeah, jump on in.
Cool. I have a little demo environment stood up here using the Astronomer CLI. I just have Airflow running locally, and this registry demo example DAG running. Not doing much right now, just 3 dummy operators: start, perform logic, and end. Again, nothing much is happening here. But let's say I wanted to actually introduce some sort of set of predefined logic in that T1, that first task that's I've identified to be the place where I'd want to execute some logic. I know that for fun, I'll just pretend that my company is a big Microsoft Azure shop, and I want to launch some sort of container image on Azure, and I want to see what's available for me to do that in the ecosystem, so that I don't need to wire up a custom integration with Azure Container Registry myself. So I'm going to check out my Microsoft Azure provider page here. I can see that this is how I install the package, and that it has a variety of available modules that I can use in my DAG. And specifically, I want to look at this Azure Container Instances operator, because that seems particularly interesting to me for my use case. What the registry allows us to do is very easily discover that this is a pattern that's first class and supported in the ecosystem. There is already code built to support this pattern, to start a container on ACI. And I can figure out how to do that quite easily, right? So if I just copy and paste this import command into my DAG file here, then we have params and docs all kind of pulled in here from Airflow source docs. This is the same kind of source as Airflow core documentation, so nothing super different here aside from minor UI tweaks. But an interesting feature that we've introduced here is this kind of example DAG graph that allows us to see any DAGs that exist in the open source that use this operator specifically. So I'm very easily able to have a contextual instance of how this operator might be applied in my DAG. So I'm just going to copy and paste that here now that I have it being imported, I believe. And pray I don't have any formatting errors here. But
so quick question, Pete. All the documentation for these providers, where is that being built from?
It's being built from Airflow source. So again, all of the docs for these things, like all of the bits that you're seeing in the UI here, are actually pulled from the doc strings at the top of each Airflow module file. So if we click over to view source, this Sphinx templated doc string is where the docs live. So anyone in the community can help implementation, of course, by going in and submitting PRs to these doc strings. And this is the same source that the Airflow docs are built on. Again, the goal of the registry is not in any way to compete or conflict at all with Airflow documentation, but rather to provide a discoverability interface that's very specific to Airflow providers and modules, and just help kind of drive that day one, 0 to 1 value layer and experience for Airflow users looking to interface with any sort of third-party service.
Yeah, especially when I'm trying a new service out, and I could see an example of how to use that new service. That would save me so much time each time, because I basically guess and check until my DAG works, and then I can start actually writing my workloads.
Exactly. Yeah, that's why it's been really, for me at least, oftentimes I want to plug in a tool that we're thinking about introducing at Astronomer to our data stack, to my DAG. Sometimes it can be tough to navigate what params I need to pass a specific operator, or even more complex, something I've done before is write my own custom operators to face with third-party APIs. This allows for a really nice experimentation framework when onboarding new tools to any sort of data stack. So again, all I had to do here was just copy and paste this task code. Again, there's some hand waviness here, admittedly, because I'm not adding my own resource or Azure creds or anything like that. My connection ID is not defined at this point, but you can imagine that this is very easy to implement if you do have an Azure store, Azure Container Instances, account stood up, and you can just log into your Azure tenant and apply the correct params to make this start container task function as advertised.
Hey, so Pete, question in the chat around some of the Azure providers.
Sure.
It sounds like that there's not support for Data Lake Storage 2 on the Azure providers right now. Is that something that the new provider framework makes easier? And if so, is there a way we can help users that are looking for support on the new Azure operators?
Totally. Like, one of the great things about the kind of Airflow 2.0 providers framework is that if you want, or anybody in the community, right, anybody in the ecosystem, but we at Astronomer also can do this, you can just write a custom operator to support one of these new services or new APIs and PR it to the Azure provider in Airflow. And it's automatically picked up and built into the next version of the package so that it can be redistributed to everybody else in the ecosystem and community. So again, one of the things that we at Astronomer at least are committing a lot of resources to in the coming 6 months to a year are evolving the operators framework and adding more operators to support some of those new popular services, so that the things that data engineers use are supported as first-class citizens. So we're looking forward to submitting a lot of PRs against these purposes in the near future. Again, folks can feel free to browse this themselves and ask questions in the chat, or get in touch. We have a nice search interface as well to help discover any sort of task or module that you might want to implement for a service that you use. S3 is just a popular one, but even I'm pretty familiar with the Airflow community and providers framework. And even as I started digging into this, there's so much that exists and so much rich work that's been done by many folks in the ecosystem and community. I'm just really excited that this helps users use more of that and find the bits that they need to be successful in their DAG writing efforts.
Yeah, this is great. It'll make life so much faster as data engineer, so I can start quickly iterating between which tools I want to use for each part of the workflow, and then just swap out that operator and just know exactly how I need to use it. Exactly.
Like we've kind of made visible example DAGs associated with these providers, so we have a lot of contextual examples of how a lot of these work. And again, looking forward to contributing many more of these as well to provide more highly contextual examples for folks to just copy and paste into their DAG files. One interesting thing too that I want to touch on before we inviting the Fivetran folks to come on and chat is we've introduced this concept of partner providers in beta along with the registry launch. One of the things that we've heard time and time again from partners over the last couple of years working in Airflow is they want to, control and build and maintain an integration for their tool, but they didn't know how to do it, right? Like they didn't know if it was right to PR the core Airflow repo and have that be managed by the community. And oftentimes when partners are controlling integrations with their own APIs. They want to be the arbiters of logic, right, for consumption of their APIs. So what we've done is we've launched these beta provider or partner providers that basically are built by Astronomer in tandem with the actual partner and company behind the tool that is being interfaced with. And we've done this with a couple of key partners to get started, and we're looking forward to doing many more of these in the coming 6 months or so. But we've worked very closely, specifically with the Fivetran team, on building a shiny new Fivetran for Airflow, so folks can easily trigger, extract and load using Fivetran syncs from their Airflow DAGs. So with that, we'd love to invite the Fivetran folks to come on and walk through some of the work that we've done around building their provider, and I think they have a demo as well.
I think that'll answer some of the questions in the chat as well.
Sure. I'm not sure how to invite them on, but I told them to. I think if they raise their hand, we can bring them on stage here. Yeah, there we go. Hey, what's up, Nick?
Can you see me?
We can.
Awesome. And you can hear me and everything?
Sure can.
All right, great. Yeah, thanks for having me, and thanks for introducing the registry and everything so far. Wanted to, just like Pete said, show what we've been working on with Astronomer. Quickly wanted to talk about what is Fivetran. So Fivetran provides automated data ingestion. So we sync data from sources that generate data like Salesforce or ad platforms, sync data from production databases that store it, like maybe Postgres, to a centralized data warehouse destination, right? So you log into something like Salesforce, log into something like Snowflake, and Fivetran does the rest. And we built out a Fivetran provider package so that you could do that in Airflow. And I wanted to quickly go over why. I think I can share my screen.
Yeah, Nick, I was going to start with that specifically. Like, I know we have been talking for quite some time, but what was interesting to you all about building a Fivetran provider for Airflow to begin with? What made you interested in embarking on that project?
Can you all see can you see my screen?
Yep.
And can you see Astronomer?
Yep, we got your Airflow instance.
Awesome. And is that it? Because I'm trying to just show a monitor that I've got over here. I don't know.
Yeah, I think that's what you got. I think AirMeet allows you to show a full monitor, and that's it.
Okay, great. So yeah, you can see a slide now, maybe.
Yep.
Awesome. Yeah. So the reason why we want to build this out in 2 words is our users, right? So our users were asking for this. A lot of our users were already Fivetran users and Airflow users, and having to build out these own integrations and call Fivetran from Airflow themselves. And a lot of different organizations were kind of re-engineering the same thing. So we wanted to just standardize that and provide that as a package, right? I think that may be a similar situation to some of the organizations on the meetup here, right? So a lot of people were redoing the same thing. And these are 3 of the things that we saw this enabled for our users building out this package. Let me go full screen here. So the first thing that would be most important would be synchronizing, or the first thing that would be important that people were looking for was synchronizing syncs. So Airflow allows you to have really fine-grained control over when things are happening, right? And it gives you an awareness and when things are starting and stopping, their dependencies, all of that stuff. And this allowed you to perform things like you're going to be able to perform transformations across different sources. So we'll see that in a demonstration. As data is coming in, maybe you have requirements where data is coming across different sources and you want to transform, you want to know when your data lands in your warehouse and then be able to transform it. That's huge for our users, and really the Airflow or something like it is really the only place that you can do that. Also allows you to prioritize syncs, right? So if I have a really big job that I want to start first, I can put that as the beginning of my DAG and have maybe my other data syncs that are less of a priority, map the dependencies from my most important things to least, and define that. Maybe I have really long running jobs that I want to run first or last, or however you want, right? Getting that fine-grained control of what's going first. And then if you're doing this with Fivetran and Airflow, it allows you to inherit the benefits that you get from Fivetran. So as we're automating data ingestion, we do things like automating changes in schema and detecting that, automating like deduplication and failure recovery and things like that, getting all of those native to Fivetran, right? So we're seeing a lot of people use and build out these same extract and load tasks natively in Python for Airflow. Using Fivetran instead of building it allows you to focus on building new DAGs instead of fixing broken ones, right? A lot of places where we're seeing DAGs break down is in the data load portion of a DAG, and being able to just offload that work into a company like Fivetran that is, what our company does, really allows you to figure out and scale out what's happening in my DAGs, I'm building out new ones, right? And then we think scale is one of the best benefits that you get from Airflow. So it really enables you to focus on that. The number one request that we were getting from our users, though, is triggering transformation. So this was the top feature request, not just for Fivetran and Airflow, but one of them for just Fivetran in general. So in Airflow, P was talking about the sensors, and like an Airflow sensor will monitor Fivetran metadata, and as soon as all the data has been Fivetraned into a warehouse, that sensor will resolve, and you can go like further down in your DAG, move on to the next task. The transformations don't happen, or anything else in downstream doesn't happen until all the data that you need to do so has been loaded, but then it happens like right away as soon as all the data is available. And like I mentioned, you can't do that in any other way other than utilizing a tool like Airflow. If transformations happen too late, right? If you're scheduling Fivetran jobs and then something like DBT that transforms data, you're spacing them far apart so that your data is in the warehouse. That can lead to latency problems and we've seen people like miss SLAs because they want to make sure that all their data for their transformation is available. Or if you schedule them like too early, EL jobs can overlap with your T jobs, and that's bad, right? That leads to missing data and integrity issues. That's also bad. So being able to have that control over when things are starting and stopping so I can move on to the next portion of my data pipeline was like the number one feature request why we built out this integration. And then, as you may know, our users are not just moving data around. They're doing things before data enters Fivetran, after data is transformed by DBT, doing a lot of BI visualizations, doing machine learning. And Airflow provides one platform for you to monitor all that. So that's another great benefit that we're seeing from this provider. People can have one place for logs, one place for pipelines, instead of managing Fivetran logs, managing DBT logs, managing Looker logs, right? Being able to all do that in one area. So I wanted to know what our provider looks like in Astronomer, but before I wanted to touch on some experiences, what it was like for us to build out this provider with Astronomer. So here at Fivetran, it took 2 developers. We were working part-time. It took us a couple weeks to put everything together. And it's like hard for me to compare how hard it was to how hard other development projects I've been on were, but having Astronomer work with us and check all the boxes that we needed to check was really helpful for us. And I think that there are a couple of things that were different about our situation that may make, if you want to build out a provider, it may make it even easier. So one is our experience. Both of the developers that built out this provider had Python experience, but no Airflow experience. Like I didn't know what a hook or an operator was before we started building out this provider.
Yeah, one thing I can just jump in with, Nick. Yeah, like one of the things that we want to highlight too, as we start to evolve the ecosystem even further, is it's really easy for anybody to get involved and build their providers. Like whether you're at a company that wants to build a provider for a tool or just an individual developer, community providers are fully supported as well. So we really just want to empower folks to be able to and share the work that they've done with other folks in the community. So, it's fairly straightforward and fairly easy to get to do. And we have a sample repo as well that we can share following the webinar that you can check out if you're interested in getting involved.
Yeah, let's see what the code looks like. I'm excited.
Yeah. Let me jump into that. So we do have, I would say, yeah, we had a lot of Python experience, and that was really the only hard requirement that I would see is like being able to do that. We don't have, at Fivetran, we don't have a Python SDK, which I think would really, we had to implement a lot of that logic as far as like parameter checking and exception handling in our Fivetran hook. So if your organization has a Python SDK, that's going to take this process that we had that was pretty easy into something that I think would be very easy. And then, as Pete mentioned, there's a lot of examples that we drew on for reference that I think really helped put together. So we have a Fivetran hook, operator, and sensor. Fivetran operator is verifying that the Fivetran job that you want to start exists, and it's kicking off that job. A Fivetran sensor is monitoring that finish, again, so I can know the second that Fivetran has moved all the data into a warehouse and move on to something else further downstream. And then you can see on my screen the Fivetran hook, which is providing that API interaction. This is kind of our most beefy portion of our provider package, where we are doing things like generating API calls and generating the URL string that would perform that API call. Again, this is a lot of things that you could be doing with DK in like 1 or 2 lines. Being able to do checks and moving logs, things around, being able to check into connector. So Fivetran defines the connection between a source where you're moving data from to a destination that you're moving data to as a vector, and we make sure that we check that that exists before you can run it. Just simple logic and things like that, to where if I show the operator, I think it's really clean and straightforward what we're doing. You get a hook, which establishes that connection to the Fivetran API. You prep a connector, you make sure it exists, you make sure that it's on an Airflow schedule, things like that, and then you start it. Right, then you have Airflow managing your Fivetran tasks. You can prioritize them, things like that. And then we have obviously a sensor that is waiting until that is resolved. The demo that I wanted to show, yeah, go ahead.
Oh, I was going to say, how does it look like in a DAG, but you're way ahead of me.
So the demo that I wanted to show, a popular use case that we're seeing is aggregating marketing data. So if you have at different various ad platforms, being able to have in one view for maybe a BI tool, being able to track your advertising spend, impressions, and clicks across, like, as you can see on my screen, LinkedIn and Twitter. So we're providing a way to do that through Astronomer and other tools. You bring in something like LinkedIn ads data and Twitter ads data through Fivetran into a data warehouse like Snowflake. And Fivetran also provides DBT packages where the model, like the raw data that we bring into your data warehouse, we provide DBT packages where you can transform that into views, like I said, that you'll be able to more easily use them for BI tools. So I'm using that as well. So we're getting that ELT, that whole pipeline, data ingestion pipeline done here in these 2 steps. And they're being performed by 3 different tasks in Astronomer. So 2 Fivetran jobs, 1 DBT job, getting the data and transforming it. And if I look at that in Astronomer, all I really need to do is define those 2 Fivetran tasks, the Fivetran operator starting each of these tasks, the Fivetran sensor waiting for them to be finished. And then you can see, so we have these 2 different data syncing into Snowflake. One finishes at about like 13 minutes after midnight. One takes a little bit longer, it finishes maybe 3 minutes after midnight. And then this stops at 43:55, and then DBT is transforming data at 43:56. So a second later, I'm transforming my data, something that a lot of our users are really looking for. They were searching for outside, maybe building it out themselves, or searching for with tools outside of Airflow. And we're really happy to be able to provide that to them in Airflow with with this provider package and with Astronomer.
Yeah, so one of the things that we want to highlight here, and like this is great, Nick, this is a great contextual example. Like this is where the provider framework in Airflow really shines, right? It's really easy to plug in the right tool for any specific job into your DAG and experiment fast, right? Like try to find what makes the most sense, both from a use case perspective, also from like a cost perspective. It's quite easy to optimize these pipelines using the provider's framework and make sure that you're using the right tool for any sort of piece of your end-to-end data pipeline. So, in this case, the Fivetran DBT example is very good. It's very easy just to grab the Fivetran provider, plug in these Fivetran operators to sync this LinkedIn data, and then, use DBT operator for some of the SQL transformation. But you can imagine how this extends more broadly to just about any sort of tool in the modern data stack.
Yeah. Let's see what the DAG code looks like. Like, how does it look once the provider is there? How easy is it for me to use?
Yeah. So this is, I think I'm doing all this in one line, maybe two. Let's look and see. I'm trying to think of where the most up-to-date DAG would be in this example.
If you just go into the Airflow UI, there's a little tab that you can click on too.
Oh, you've got a code tab? Where is that at?
Yep.
Oh,
right on the right there.
Yeah, so I guess we're doing it in 3 lines, right? So this is really flexible for us too, right? Because we have some users that they want to transform data when all of their data has been Fivetran like into a warehouse. We also have other users that are like, anytime there's new data that's arrived, I want to transform each time. So we can take care of both use cases in like one line of code, right? The only difference would be breaking this line out into 2 lines. So I have an and situation here. Like once LinkedIn is done and Twitter is done, transform my data. It's super easy to make that an or situation. Once LinkedIn is done or Twitter is done, transform data. And then all we're doing with the provider packages, the biggest reason why we're seeing people use Fivetran is because it's easy to use. And we were still able to, with like Astronomer, capture that in a provider where all you need to do to get this running is Fivetran connectors between sources and destinations are defined by connectors, right? And each of them has a connector ID. You copy that and then paste it in Airflow variable, and that's all you need. You need that in an API key and secret, and the package really, or the provider takes care of the rest.
Yeah, there's more info on the provider page that we can share for sure if folks are interested in taking a look. Nick, thanks so much for joining and walking us through this. This is awesome.
Yeah. Thanks for having me. Thanks for working on this with us. I think if you want to, present or build out one of these providers, some of the examples really helped me. So hopefully, our example can help you. And especially if you maybe don't have a Python SDK, the way that we've kind of pushed all of that logic that you may have into a hook was, I think would be valuable for someone maybe starting this now.
Love it.
Yeah, thanks for having me.
Thanks, Nick.
Yeah, well, I guess we'll do a quick transition over to questions, Viraj. I think we have almost about 10 minutes left. Does that sound good to you?
Totally. There's a ton of good questions in the chat here, Pete. So I'm just going to stop to you, and we can take our best crack at answering them.
Sure.
How do we know which Airflow provider is compatible with each specific version of Airflow?
Yeah, so there are constraints published. We're working on really making that it's super, super clear what versions of providers are working with which versions of Airflow. The community's done a lot of work around, validating that with each Airflow release, each provider that is being released is compatible. But look out for a lot more coming your way soon, specifically on that piece.
Yeah, don't want to tease too much here. So what's the recommended way for adding a provider that's already inside of Airflow? Leo is asking for specifications around changing something related to the Azure provider.
Yeah, no, that's a really good question. There are a couple different ways you can go about doing it, right? Like, obviously, what we want to avoid is forking in any way. We'd much rather have those changes make their way back into the package itself. We'd rather you not have to maintain a custom fork of the provider. There are a couple different things you can do based on what you have to do. One of which is the obvious is PR the actual provider directory with any relevant changes that need to be made, or you can just create a separate operator and throw that into the actual provider package itself. Alternatively, you can take that base operator and extend it basically by wrapping it in its own Python class and adding some extension logic there.
Yeah, that's definitely a lot easier than how it used to be. Pete, what's your opinion on having versioning for different operators and as well as different DAGs?
Super important. Super important. I know DAG versioning specifically is a feature the community has been working on for a long time, and I know the Airflow PMC and folks working on core Airflow are have done a ton of work on that. I'm really excited to see that make progress. Specifically with operator versioning, I think it's crazy important. These things change over time. Even if the call stays the same, API versions change. API methodologies change, connection logic changes. You want to make sure that you're able to upgrade reliably without breaking anything. You want to treat your operators like you would any software project, right? Software project that you're using in the context of your data stack, and you want to make sure that they're versioned and tightly monitored so that any sort of changes are tested before being pushed to production. So I think, again, the providers framework wants to do is really maintain a tight eye over versions of these things and make sure that they're easy to upgrade for one, but also allow you to maintain a certain degree of reliability and responsibility.
Exactly. I couldn't emphasize that more. That was so well put. Questions about certifications. So if I can't afford a certification due to cost of living, what options do we have for people in that situation, or students or something as well?
That's a great question. We'll have to sync with our training team on that. I'm sure that there's something that we can do. If folks have that problem or concern, can you shoot us an email? You can email us at ecosystem@astronomer.io. I'll drop that in the chat too, and we can get you in touch with folks on our side. Or maybe, I think we do have a training alias as well. I don't know if Mark is here in the chat, but if he's not, then we can get you in touch with him.
Cool.
Shoot me an email there and we can see what we can do for you.
A few more questions. So as far as help with Airflow on Azure, from TravelClick, if that's something you're looking for help on because there's no native Airflow service on Azure like there are in AWS and GCP, shoot us an email. You can hit humans@astronomer.io or just me, Viraj@astronomer.io. The follow-up email will have all of our contact info, and we'd love to help. So there's two more questions here.
It's almost like that's something that you've had to do before.
Once or twice. Yeah. Resources, how to extend and build a custom operator. Where would I find something like that?
Yeah, so we have a sample header repo on GitHub now that will help. That's designed to help users build operators and bundle them up into provider packages that they can share either with their teams or with the broader community. We'll love folks' feedback on this. Again, it's we launched it last week with the Astronomer registry. I just dropped it in the chat. We'll include it in the follow-up to all attendees. But there should be resources in there on how to best structure and build a custom operator and package it up in a safe and way that mirrors compatibility with all the other providers in the community.
Another question from Bhaskaraj. Do we have any implementations, pointers, or integrations around using Control-M with Airflow?
Yeah, I mean, we would actually work with you on that. This is something that we've explored. So if that's something that you're interested in, please do feel free to email that ecosystem alias I dropped in the chat. We'd love to chat and figure out what the right abstraction layer is for that specific use case.
Awesome. So it looks like a question from India here. I'm running 9,000 DAGs and things are getting stuck with 13 schedulers. Is that something that we can help with, Pete?
Definitely. I mean, I feel like this is kind of venturing outside of the realm of Airflow providers, but this is something that Astronomer has done many times. So again, feel free to get in touch without chilling too much or anything like that. It's something that we are able to help with if it's interesting.
Shoot us an email, please. This is also a question for our training team, but Pete, maybe if there are additional certifications on the way and what the timeline around that looks like.
Yeah, there definitely are. I know Mark and company are working really hard on getting a couple new certs out there. I think there are plans around kind of airflow infrastructure and machine learning in airflow and kind of more highly contextual use cases in airflow. I don't know when they'll be out there, but definitely keep an eye out.
Cool. Just a quick note in the chat here.
Mark is here.
A promo code for you all to use from the webinar for the certification, welcome-webinar. I'm dropping it right in the chat, and we'll also shout in the email afterwards as well.
Nice.
Looks like
question.
Last question here. Airflow and SAS Data Integration Studio. Is that something we could help build?
Yeah, I actually haven't seen anything out there in the wild, because it's something that I've had a lot of conversations with. Kind of the same answer as the Control M. We'd love to work with you on it. Please do email us. I think the question at this point is more around what's the right abstraction layer, not is it possible or is it doable, because we know it's very well possible and it's something that a lot of folks can benefit from. So something that we'd be interested in sinking our teeth into.
Yeah, would love to figure out the right way how to do that. The what is definitely something that we can do. Just need to figure out the how. Alrighty. Does not look like there are any questions. Oh, just got one more here. Let's see. Recording of the webinar. Yep, it'll be sent out in an email follow-up that all the attendees should get, as well as available in our blog in the next day or two.
The only last thing, Raj, before we skip is if folks have feedback about the Astro registry as you're browsing, anything we can do to improve the experience, please do get in touch and let us know. We have some exciting plans on how we are looking to extend that to build a better experience around actual DAG debug for users. So keep an eye out, and always open to hearing feedback and having conversations with folks that are interested in using it. So please do reach out.
Awesome. Well, thanks for joining, everyone. Loved all these questions and the discussion that took place here. If you have any follow-up questions or anything else of the sort, please feel free to email us at any of the sites of any of the links that we provided. The recording, sample code, and everything else will be sent out to you shortly afterwards. Thanks again for Fivetran and Nick for presenting. And yeah, hope this got your week off to a good start. We'll see you in 2 weeks, where we'll announce our next webinar topic. And I'm excited for the next one, so more to come.
Thanks, folks.
Awesome. Thanks, everyone.